Hey guys! Welcome back to the laboratory. In this video, we are looking at velocity time graphs. By the end of this video, you should be able to identify the use of velocity time graphs, draw and interpret velocity time graphs, and calculate acceleration and distance using velocity time graphs. So, let's go! The velocity of an object is a measure of its speed in a particular direction. We can use velocity time graphs to provide a visual representation of how an object's velocity changes over time. Let's look at this velocity time graph as an example. At point A, we have an upward sloping straight line. On a velocity time graph, this line indicates that the velocity of the object is increasing. We can confirm this by looking at the values along the x and y axis of this graph. As the line slopes, we see that the velocity of the object is increasing from 0. This positive increase in the object's velocity indicates positive acceleration, which means that the object is speeding up. At point B, we have a horizontal line above the x-axis. On a velocity time graph, a horizontal line marked above the x-axis indicates that the object is moving at a constant velocity. Once again, we can confirm this by looking at the values along the x and y-axis. Although time is passing, the velocity of the object remains constant. This means that the speed and direction of the object are not changing. Therefore, the acceleration of the object is 0. At point C, we have another upward sloping straight line. Much like at point A, this line indicates that the velocity of the object is increasing. However, at this point in the journey, the velocity of the object is increasing much faster than it was at point A. We can identify this by looking at the steepness of the line. The steeper the line on a velocity time graph, the quicker the velocity is changing. At point D, we have a downward sloping straight line. The downward slope of the line indicates that the velocity of the object is decreasing. This negative decrease in the object's velocity indicates negative acceleration or deceleration, which means the object is slowing down. And finally, at point E, we see another horizontal line, but this time along the x-axis. The meaning of a horizontal line along the x-axis of a velocity time graph is different to the meaning of a horizontal line above it. Therefore, it's important that you remember the difference between the two. When a horizontal line falls on the x-axis of a velocity time graph, this means that the velocity of the object is 0. Therefore, the object is stationary. Because the acceleration of an object is equal to its change in velocity over time, we can use the gradient of a line on a velocity time graph to calculate the acceleration of an object at different parts of its journey. To achieve this, we would use the equation linking acceleration, velocity, and time. For example, let's say we wanted to calculate the acceleration of the object at point A in the journey. The gradient of the line at this point in the journey is equal to 10 meters per second minus 0 meters per second divided by 10 seconds minus 0 seconds. This means that the acceleration of the object at point A is equal to 10 divided by 10, which gives a total of 1 meter per second squared. We can also use velocity time graphs to calculate the distance travelled by an object. This is achieved by calculating the total area under the section of the journey that you wish to find the distance of. For example, let's say we wanted to calculate the distance travelled during this shaded region of the journey. As this section of the journey includes a slope, we must divide this shaded region into a triangle and a rectangle. Now we can calculate the area of each of these shapes and add these values together to find the total area and thus the total distance travelled. To find the area of a triangle, we must do 1/2 multiplied by the base of the triangle and its height. And to find the area of the rectangle, we must do the base of the rectangle multiplied by its height. So, the area for this triangle would be equal to 1/2 which we'll write as 0.5, multiplied by its base, which is equal to 10, and its height, which is also equal to 10. This calculation gives us a total of 50 meters for the area of this triangle. And the area of our rectangle is equal to its base, which is equal to 30, multiplied by its height, which is equal to 10. This calculation gives us a total of 300 meters. Finally, we add these two values together to find the total area of this shaded region. 300 plus 50 is equal to 350. The distance travelled during the shaded region of this velocity time graph is equal to 350 meters. And that's it, guys. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon.